Hi students, today in this session, so I given some examples based on the bond length. So here is in the question, we have to find out there is a bond length between the carbon and oxygen in the given three options, which has the more bond length between the carbon and oxygen. So we have to find out. Okay, in the last class, we discussed about bond length, which factors are based on the bond length, that is the over. Okay, so now come to this question. First of all, we have to find out the pure single bond and pure double bonds. So let us see. Here is the carbon between the oxygen. There is a pure single bond is there. Pure single bond is there. So obviously the first one is the having more bond length between the carbon and the oxygen. And let us see the second one option. There is a conjugation will be there. Double single lone pair. There is a electrons are involved in the resonance. So if there is a electrons involved in the resonance, this single bond becomes to formation of partially double bond. So like this, there is a carbon single bond and carbon getting negative charge, and between the carbon and hydrogen, there will be formed the partially double bond and oxygen getting the positive charge. Right. Finally, we have here is getting the two resonating structures by this component. Okay. So let us see in this session, in this option, there is a lone pairs are involved in the resonance. By the way, there is a benzene also, there is lone pair of there is a pi bond electrons also involved in the resonance. Okay. Here is a double bonding nature between the carbon and oxygen. There is a more due to there is a resonance is excess, and a double bonding formation between the carbon and oxygen partial double bond nature is excess compared to the second one. So finally, this bond length will be shorter due to the resonance is excess and forming the double bond also. So finally, there is a single bond becomes to double bond due to resonance. So there is the bond length will be decreases. So maybe there single bond, here is a single bond is there, yes or no? Due to the resonance, double bond forming, we know that like this the double bond is formed. Here is also, once these electrons maybe come to the benzene side, then automatically this oxygen getting minus and oxygen getting like partial double bond. So then after these negative electrons come to the like the involved in the resonance, we getting 5 resonating structure like this. So finally total resonating structure we getting 5 here. So already it's how it is getting the 5 resonating structures in the previous class is over. So I given one example is here. Like this resonance is possible again and again. Totally how many is there formed? 5 resonating structure will be formed. So finally there is a oxygen and carbon double bonding nature is a more compared to the second one. So where there is a single bond becomes to double bond by the resonance. Okay, so the number of resonating structures is there in the formation of single bond to double bond. So there is a bond length will be decreases. So finally come to the second and third, there is a carbon and oxygen is shorter, and carbon and oxygen bond length is a longer. Due to there is a resonating structures is excess will be formed. Here is a resonating structure, there is a 5 and there is a 2 only. Okay, so single bond becomes to double bonding nature is more than the second one. Yes or no? More than the second one. So then carbon and oxygen bond length will be very shorter. So finally the second one is greater than third one. Okay, understood? So single bond becomes to double bond. Okay, single bond becomes to double bond. Here is a again and again there is a resonance is also possible. So that's why this partial double bond is having the more time. Okay, so this partial double bond is placed more time. Okay, so finally here is a carbon and oxygen. There is a partial double bond is there is short time will be present. So again it is to turn to the single bond quickly. But here is a take the 5 resonating structures, after it will be getting the single bond. Come to this structure after 5 resonating structures. So that's why there is a partial double bond is which is present on the phenol. That is it is to present more time. So finally, so there is a carbon and oxygen is the bond is there now, partial double bond, that is very shorter than compared to the second one. Understood? Right. So next one, come to this one. Second question. There is in the second question here is a single bond. So your question is carbon and nitrogen bond length which has more. So now here is a single bond is there, na? Single bond. So this is a single bond, is the pure single bond. So we know obviously this is a long or more bond length between the carbon and nitrogen. So the first option is the first. Okay. Then come to the, here is a single bond becomes to double bond. So there is lone pair electrons involved in the resonance. But here is a resonating structure we getting 2 also. And here is a nitrogen consists 2 lone pair of electrons, and there is a 2 pi bonds are there. So compared to the first and second, there is a resonating structures is more. And come to this one, here is a lone pair of electron when they are involved in the resonance. So we have getting the more number of resonating structures compared to the second, third. So we give the 1, 2, 3, and 4, and 5. So obviously where there is a single bond present between the carbon and nitrogen, that will be the more bond length. And come to the second option and third option. Here is the double bonding nature is excess. So the partial double bond will be present more time. So here is a partial double bond is present quick time. So finally here is a second number, then after third, then after fourth, then after fifth. Fifth, there is a pure double bond is there, no? There is a present between the carbon and nitrogen, there is a pure double bond. There is a pure double bond. If there is pure double bond is there, pure double bond is there, bond length will be less. Come right there. So finally, finally there is a pure double bond. So this is a fifth one. So come to the first one is a single bond. So this is a fifth one. Okay, right. Next come to the 10th question. So here is a same question between the carbon and nitrogen which have more bond length. So that's your question. So we have to find out the carbon and nitrogen single bond. This single bond is a pure single bond. Okay, but here is a CH3 which is plus I, and this is the minus M. Okay, right. Now here is a lone pair of electrons are there. Here is also lone pair of electron, and we give the first number, second number, third, and fourth number. Now there is a pure double bond. Here is a pure double bond. So obviously that is a very shorter bond between the carbon and nitrogen. And come to this first one. First one is the first we know already. So last one, fourth number is the last. So in these two, which will be to having the larger or long bond between the carbon and nitrogen. So let us see. Minus M group is the electron withdrawing group. So it can be to attract the electron from the benzene, as well as benzene also to attract the electron from the nitrogen which is present on the benzene ring. So there is a pi bonds which is partially double bond is forming now between the carbon and nitrogen, that will be to form the very quickly. Then compared to the CH3, due to here is the plus I group or plus H group, it is now electron donating group. So that's why here is the lone pair of electron involved in the resonance, but compared to the second one, compared to the third one, second means in both second. So in the option second and the third, there is in the second there is an electron donating group there, and the third one electron withdrawing group is there. So finally here the lone pair of electrons easily not coming to the benzene side, but here is a lone pair of electrons will be come to the easily to the benzene side, due to here is a minus M group will be there on the benzene ring. So that's why these lone pair of electrons will be form the partial double bond is very quickly. So compared to the second option, due to here is the CH3 group donate the electron to the benzene. So that's why the benzene is not easily to accept the electron from the nitrogen. So compared to the second and third, there is a second bond length between the carbon and nitrogen is excess. It will be also to form the partial double bond, but it is not quickly from the partial bond. So it can be to form the easily partial double bond due to here is a NO2 groups. So NO2 groups, electron withdrawing groups, they can to accept the electron from the benzene, as well as benzene to take the electron from the nitrogen lone pair of electrons. Those there is a partial double bond is will be formed very quickly. Okay. So finally, so partial double bonding nature compared to the second and third, there is a easily formed in the third one. Okay. So that's why this partial double bond which is to present between the carbon and nitrogen, that is will be present very more time. So finally, second and third and then fourth. Okay, right. Next come to the question number 12. So we know that here is a single bond is there, here is also single bond is there, and here is a question is what carbon and oxygen bond length. So bond length we have to mention which has the more first. So we have to give the first option, second option, and third option. And we know that here is a pure double bond is there. So this is obviously less bond length between the carbon and oxygen. And we know that this is the electron withdrawing group. This is a minus I group. We know that. So this is the ortho position. This is the meta position. Right. So here is a resonance also possible. And here is also resonance is also possible. Okay. But here is a no resonance. But this is a pure double bond. Here is a single bond getting the partially double bond. Here is also single bond getting the partial double bond. In the both case, there is a double bond will be formed between the carbon and oxygen. But which will be to easily form partial double bond. So this one will be easily form the partial double bond because here is a minus I group is present. So it will be to electron withdrawing group as per the inductive effect. Due to it, the meta position inductive effect is possible only. So that's why here is a partial double bond which is present between the carbon and oxygen, that is will be shorter. Due to there is a partial double bond will be formed very quickly than compared to the first one. So the first one is the more bond length between the carbon and oxygen, then second one, then third one. So here is the resonance also there, here be also there, but there is a quick resonance in the present of second option only. But in the third option, there is a carbon and oxygen, there is pure double bond. Already there is a pure double bond. Pure double bond is a very shorter. Okay, right. So finally, the first, second, third. Understood? Right. In the given question, there is a first, second, third, and fourth. So which has a long bond length or bond length is more between the carbon and carbon. That is your questions. The first one is the first due to the pure, and second one is the less compared to the third one due to the resonance is the. There is a resonance is less. Here is a resonance is more. So here is a double bonding nature is excess. Here double bonding nature is कम. So जिधर double bonding nature ज़्यादा हो रहा है single bond का तरफ, so उसका bond length क्या होता है, कम ही होता है. तो इसमें only two resonating there is only two pi bonds will be there compared to the benzene and this one. Here is the resonance is possible only like this single bond is becomes to double bond and this single bond becomes to double bond, but not here is a single bond and single bond. There is will be present only. So but here is all the single bonds will be converted into double bond. So where there is the single bonds becomes to double bond is forming by the resonating structure. So that will be to consist the bond length is very less. So finally we choose the first option is the first due to the pure, and there is a second option, then is the third option, and this is a pure double bond also. This is a shorter. And come to this question. So obviously your question is a carbon and oxygen bond length which has more. So अपन क्या करना है, कार्बन ऑक्सीजन के बीच में किसका बॉन्ड लेंथ ज़्यादा है वो बताना है. So we have to find out the bond length between carbon and oxygen. So first of all you listen here. This is a pure single bond. So pure single bond that will be to the first. Okay, right. The last one is the E. Due to this is a pure double bond. This is a pure double bond. So the next one here is also pi bonds will be there in the ring. So this is the benzene. Right. Come to this will be the plus I or plus H. This is the minus M group, or D group is the minus M. And compare the B, C and D, which will be consist the carbon and oxygen is more bond length. So that's our question. So finally this one is give the electron to the benzene. So the benzene is easily not accept the lone pair of electron from the oxygen. But here is a phenol, there is no any group donating or withdrawing group. So here is a lone pair of electron as usually. So come to the benzene side. So getting the resonance, and here is also lone pair of electrons involved in the resonance. So getting the resonating structures. So in these three options, where there is a partial double bond will be formed very quickly, obviously. So in that D there is a partial double bond will be formed very quickly, and the carbon and oxygen bond is very shorter. Okay, single bond becomes to double bond. But here is the one case is there. That case is electron withdrawing group is present. That's why these lone pair of electrons very easily to comes to the benzene side, and very easily to form very quickly to form there is a partial double bond. So very quickly. So obviously, so E after D will become, then after C will become, then after B will become. So there is a B. We know already this one to donate the electron donating group. So that's why these lone pair of electrons easily not coming to the benzene side. So compared to the phenol, and this will be to late partial double bond will be formed. But here is a quickly double bond will be formed. So finally, the order is the bond length, the first, second, third, fourth, and fifth. Understood? So I will give you some more example in the next session. So keep it in mind these rules. So there is maybe double bond becomes to single bond, or single bond becomes to double bond by the resonance. So there is a first case. If there is a first case, single bond becomes to double bond, single bond becomes to double bond. So there is a bond length will be decreases. If in the case double bond becomes to single bond by the resonance, their bond length will be increase. So these concepts, keep it in mind. I will give some more example in the next session. So understood this one? So first pure single bond is the more bond length, and a pure double bond is the very shorter. So between the pure single and pure double bond, there is a resonating structures will be coming. Okay, so resonating structure, if there is a double bond forming is excess, there is maybe partial double bond forming is more by the resonating structures, that will be consist the bond length very short. So here is a very short bond length. Okay, so this is the concept of bond length. I will give some more example in the next session. Okay, keep it in mind.